Alright, in this video I'm going to talk about what percent yield means. Okay, so if we have the reaction where we have 2 A's react with 3 B's to give 5 C's, and we're given 8 moles of A and 7 moles of B, and we want to know the maximum number of moles of C, so we're looking for moles of C that can be produced. So this is going to be a limiting reagent question, because we have 2 reactant amounts. So I'm going to first calculate how many moles of C can be produced from 8 moles of A, and then how many moles of C can be produced from 7 moles of B. Alright, so I've got 8 moles of A, and move that up here, and I've got 7 moles of B. Okay, so in order to go from moles of A to moles of C, I have to use a mole-to-mole ratio, and so my mole-to-mole ratio is going to be 2 to 3. So 2 moles of A to 5 moles of C. And then down here on the bottom, from B to C, I've got 3 moles of B to 5 moles of C. So 3 moles of B, 5 moles of C. So moles of A cancels with moles of A. And if I calculate that, I get 20 moles of C. Oops, what am I doing? So then if I calculate this, I've got 35 divided by 3, that's 11.6 moles of C. And so the most that I can make is 11.6 moles of C. At that point, I do not have any more B to react, and so I can't make any more. So that's the maximum amount. Okay. All right, so this right here that I circled in blue is called your theoretical yield. And it's based in theory, and so it's what you should get in the lab. Okay, and you could also say that it's what you calculate. So whenever you do math and you're not doing anything in the lab, it's what you get when you calculate it. All right. So then let's say that we do this in the lab. So you perform the reaction, and obtain 10.2 moles of C. And you would want to know what is the percent yield. All right, so with that, we have to define another word before we can talk about what percent yield is. We have to define actual yield. And so this would be your actual yield. And your actual yield is what you actually get when you do the reaction. So it's what you get in the lab. Okay, so if the theoretical yield is what you should get, and the actual yield is what you actually get, they're not going to be the same, because whenever you do a chemical reaction, you're never going to really get, most of the time, sometimes you could get very close, but a lot of reactions you're not going to get 100%. So in order to find the percent yield, the percent that you got, you have to compare the two numbers. So the percent yield is the actual yield divided by your theoretical yield times 100. Okay, so if we were to calculate the percent yield for this reaction, we would take, our 10.2 moles that we got right here, and we would divide that by our theoretical yield that we got up here, right? Which was 11.6 moles. And then to make it a percent, we have to multiply by 100. And so we end up with 87.9%. So this reaction had an 87.9% yield. We got 87.9% of what we should have gotten. Okay, so let's do one more problem. We have 5 moles of N2 and 12 moles of H2. What is the theoretical yield of NH3 in grams? So we're given 5 moles of N2, 12 moles of H2, and we're looking for the grams of NH3. Remember, theoretical yield is just what you would normally calculate. So I'm going to start with 5 moles of N2, and I'm going to go ahead and write down 12 moles of H2 so I don't forget to take a look at that too. So again, this is a limiting reagent problem because I'm given two different values here. Two different reactants amounts. So next I have to do a mole-to-mole ratio, N2 to NH3. So I have 1 mole of N2 to 2 moles of NH3. And then because I want this in grams, I have to use the molar mass. So 1 mole of NH3 for 17 grams of NH3. So that's 5 times 2 times 17, which is going to be 10 times 17, or 170 grams. And then on this one, I do a mole-to-mole ratio of hydrogen to NH3. So that's going to be 3 moles of H2 to 2 moles of NH3. And then again, this 17 grams of NH3 for 1 mole of NH3. And so I'll get 4 times 2 is 8 times 17 is 136 grams of NH3. So since this is a smaller amount, that's my answer, right? Once I've made 136 grams of NH3, there's no more hydrogen, and so that's the most that can be made. All right. So then down here at the bottom, I want to calculate the percent yield, and it looks like I've got 108.3 grams of ammonia that I got out of the lab. So I'm going to take 108.3 grams and divide by my theoretical yield, which was 136, and multiply by 100. And my percent yield from that would be 79.6%. So that's it for percent yield. Good luck.